Technology has always advanced in aviation. Global awareness of climate change and sustainability puts pressure on the industry to cut emissions while preserving efficiency and profitability. Rolls-Royce, a century-old engineering powerhouse, is leading these demands. Rolls-Royce's UltraFan engine might revolutionize aircraft propulsion. This engine represents a significant advancement, setting new benchmarks for fuel efficiency, environmental sustainability, and operational efficiency. This extensive video covers UltraFan's history, its innovations, and its wider consequences. Number 6. The beginning of UltraFan. What steps did Rolls-Royce take to transform more than 10 years of study into the groundbreaking UltraFan engine? The UltraFan project is the result of more than 10 years of extensive research and development by Rolls-Royce, demonstrating the company's commitment to the advancement of sustainable aviation. This innovative program emphasizes the increasing significance of environmentally friendly technology as the globe moves toward more sustainable energy sources. The UltraFan was created to tackle a number of significant problems that the aviation industry is now dealing with. The initiative was mostly motivated by environmental regulations. Aviation is responsible for about 2/3 of the world's carbon emissions, which has led governments and regulatory organizations to implement stronger emissions regulations. In order to satisfy these needs, manufacturers have been forced to develop new technologies that are cleaner and more efficient, and that also match with global environmental standards. The UltraFan actively assists these efforts by drastically decreasing emissions via better fuel economy. Another important aspect was the increase in fuel prices, which is a constant worry for airlines since fuel makes up around 30% of their operational costs. The UltraFan enables airlines to lower their operating expenses while still making a profit, even when fuel prices are unpredictable, by increasing efficiency. The UltraFan's development was also significantly influenced by advancements in technology. Rolls-Royce was able to create an engine that was just theoretical before due to advancements in material science, computer modeling, and state-of-the-art manufacturing procedures. The ambitious target was to produce a 25% increase in fuel economy over its predecessor, the Trent XWB, which powers the Airbus A350. This incredible accomplishment was made possible by invention, teamwork, and dedication. It firmly establishes Rolls-Royce as a leader in sustainable aviation and sets a new standard for future engine technology. Number 5. Important technological developments. In what ways does a variable pitch fan system improve engine performance and reduce noise? The UltraFan is a revolutionary engineering achievement that incorporates cutting-edge technologies such as a variable pitch fan system, lightweight composite materials, and state-of-the-art thermal efficiency to redefine performance, sustainability, and fuel efficiency in modern aviation engines. Architecture of geared turbofan. How does a power gearbox revolutionize the efficiency of jet engines like the UltraFan? The geared turbofan design of the UltraFan is one of its most innovative features, as it is a departure from the traditional configurations of engines. In traditional engines, the fan and turbine are connected directly to each other, which often restricts how efficiently each one can operate. The UltraFan addresses this issue by using a power gearbox that separates the fan and turbine, which enables both to run at their most efficient speeds. This one-of-a-kind design greatly improves fuel efficiency and the performance of the engine as a whole. The gearbox integration allows the fan to rotate more slowly while the turbine runs more quickly. This leads to a reduction in noise levels and an increase in fuel efficiency. When the fan speeds are slower, drag and fuel consumption are reduced. When the turbine speeds are faster, the engine's core performs at its best. The UltraFan is a more environmentally friendly option for future aircraft because these improvements help address two major concerns in aviation: rising fuel costs and noise pollution. On the other hand, it was a considerable engineering challenge to create a gearbox that could manage the enormous amount of power produced by the engine, which can reach up to 64 megawatts. Rolls-Royce engineers addressed this issue by using cutting-edge materials and advanced manufacturing methods to develop a strong and dependable system that is capable of enduring extreme operational conditions. The outcome is a revolutionary design that improves both performance and sustainability in the aviation industry. Fan system with variable pitch. Why is the variable pitch fan system considered a significant achievement in jet engine design? The variable pitch fan system is another new element of the UltraFan, marking a first for commercial jet engines. Unlike typical engines whose fan blades operate at a set angle, the UltraFan's fan blades can alter their angle during flight. This helps the engine to maximize its performance throughout several flight stages, including takeoff, cruising, and landing. The benefits of this method are enormous. First, it boosts overall fuel economy by altering the fan blade angle to suit varied circumstances, minimizing fuel usage throughout all phases of flight. Second, the technique removes the requirement for thrust reversers, a vital component in conventional engines used to decelerate the aircraft after landing. This decrease in components not only lowers engine weight, but also boosts dependability and eliminates mechanical complexity. Furthermore, the variable pitch fan design helps to reduce noise, making the UltraFan substantially quieter. This is particularly advantageous for fulfilling increasingly severe airport noise standards, enabling a more sustainable and passenger-friendly flying experience. Advanced materials. What function do carbon composite fan blades play in lowering engine weight and boosting fuel efficiency? To accomplish weight reduction without losing durability, Rolls-Royce included innovative materials in the design of the UltraFan. One such breakthrough is the use of carbon composite fan blades, which are both lightweight and incredibly sturdy. These blades greatly lower the total weight of the engine, immediately boosting fuel economy by reducing the engine's overall mass and improving its performance. Ceramic matrix composites, CMCs, were also used in the engine's components that are exposed to high temperatures. CMCs are built to endure extreme heat and maintain their structural integrity even in the most challenging situations. Rolls-Royce improves the thermal efficiency of the engine by using CMCs, which reduces the need for complicated cooling systems. The UltraFan's exceptional performance, efficiency, and durability are due in part to the combination of lightweight and heat-resistant materials, which establishes a new benchmark for sustainable aviation technology. High bypass ratio. How can increasing the volume of air that bypasses the engine core result in flights that are quieter and more efficient? The UltraFan has a bypass ratio of 15:1, which is one of the greatest in the aviation sector. This ratio indicates that for every unit of air that flows through the engine's core, 15 units of airflow surrounding the engine instead of going through it. The engine's overall efficiency is greatly affected by this design. The engine produces more thrust while using less fuel by allowing a greater volume of air to bypass the core. As a result, the UltraFan is a very fuel-efficient engine, which lowers the operating expenses for airlines. The high bypass ratio is important for reducing noise, in addition to its efficiency. The increased bypass airflow helps muffle engine noise, resulting in a quieter operation. This is especially important for airports in urban areas, where strict noise regulations are enforced to reduce disturbances to nearby communities. The UltraFan is a revolutionary development in the field of aviation today because it combines high efficiency with a quieter performance. Improved overall pressure ratio. How does a pressure ratio of 70:1 enable the UltraFan to collect the most energy from combustion? The UltraFan has a pressure ratio of 70:1, which makes it unique in the aviation sector. Because of this high pressure ratio, the engine compresses the incoming air to 70 times its original pressure before combustion, which allows it to extract the greatest amount of energy from the fuel. The engine may become more efficient by improving this process, which allows it to turn more of the energy from the fuel into thrust while producing less waste. The UltraFan is a more ecologically responsible and cost-effective option for the aviation sector, since it has better combustion efficiency, which leads to less fuel consumption and fewer emissions. Number 4, development milestones. How did the UltraFan exceed its power and efficiency objectives during full-scale testing in November 2023? The UltraFan project has completed numerous major milestones that demonstrate its potential. First test run, May 2023. In May 2023, Rolls-Royce successfully completed the first test run of the UltraFan demonstrator at its advanced testing facility in Derby, UK. During the test, the engine achieved a bypass ratio of 14:1, which, while slightly below the target of 15:1, still showcased the engine's remarkable design and efficiency capabilities. This milestone was an important event for Rolls-Royce, since it represented the first time the UltraFan worked as a completely functioning system, verifying the performance of its novel components, such as the gearbox and variable pitch fan. The success of this test demonstrated that the engine has the potential to achieve its ambitious goals for efficiency and sustainability, bringing Rolls-Royce closer to revolutionizing the future of aviation. Full power testing. November 2023. The UltraFan demonstrator reached thrust levels of over 85,000 pounds by November 2023, exceeding its design target of 80,000 pounds. This accomplishment represented a major advancement in demonstrating that the engine is able to provide remarkable power while still prioritizing fuel efficiency. The UltraFan was shown to be capable of not only meeting, but also exceeding the high-performance standards that are necessary for modern commercial aviation, as demonstrated by the success of these tests. This breakthrough opens the door for the engine to be integrated into commercial aircraft in the future. It represents a significant advancement in aviation technology, with the potential to transform fuel efficiency, lower emissions, and improve operational economics throughout the industry. Number 3, consequences for the aviation industry. In what ways could the UltraFan change the way the aviation industry approaches sustainability? The UltraFan engine is a game changer because it provides improved efficiency, lower emissions, and quieter operation. Its cutting-edge design has the potential to revolutionize the aviation sector by establishing new benchmarks for sustainability and operational effectiveness. The effect on the environment. Can airlines use advanced engine technology to comply with tougher environmental laws while still making a profit? The UltraFan's enhanced fuel economy results in a reduction in carbon emissions. This is in accordance with the International Air Transport Association IATA plan, which is the industry's commitment to achieve net zero emissions by 2050. Sustainability goals. The engine's performance helps airlines comply with stricter environmental rules, making it a popular option for future planes. Operational efficiency. How will fuel-efficient engines affect airline operating plans in the coming decade? The UltraFan's decreased fuel consumption delivers considerable cost savings for airlines, which is essential in an industry where fuel charges frequently contribute to almost 30% of total operating costs. By cutting fuel use, airlines may drastically decrease their operating expenses, enhancing profitability. Additionally, the engine's greater efficiency might make long-haul flights more economically viable, allowing airlines to explore new routes and markets that were previously unprofitable. This might lead to larger worldwide networks, further improving the competitive advantage for carriers adopting the UltraFan. Competitive edge. Could this technical advance upset the balance of power in the aviation engine industry? The UltraFan enhances Rolls-Royce's position as a pioneer in aircraft propulsion, highlighting the company's dedication to innovation and sustainability. With its sophisticated characteristics, such as a bigger fan diameter and a variable pitch mechanism, the engine stands out as a highly efficient solution for makers of next-generation aircraft. This might affect market dynamics by luring more aircraft makers seeking cutting-edge technologies to fulfill rising environmental criteria. As a consequence, Rolls-Royce might gain a considerable competitive edge in the fast-evolving aircraft market. Influence on aircraft design. How may the UltraFan's revolutionary features inspire the next generation of aircraft? The UltraFan's revolutionary features, notably its bigger fan diameter and variable pitch technology, have the potential to inspire totally new aircraft designs. These developments might lead to more aerodynamic airframes, enhancing overall fuel economy and performance. Aircraft builders may study methods to enhance wing designs, engine location, and airflow dynamics to complement the UltraFan's capabilities. By incorporating these new technologies, the aviation industry might see a surge in innovation, pushing the frontiers of efficiency, sustainability, and design in the next generation of aircraft. Number 2, challenges and considerations. What challenges does Rolls-Royce encounter in certifying the UltraFan for commercial use? While the UltraFan has enormous promise, its development and integration into the aviation ecosystem offer hurdles, including high initial costs, scaling manufacturing, guaranteeing consistent quality, satisfying demanding testing requirements, and persuading stakeholders to accept the technology. Certification and regulation. The UltraFan engine must undergo comprehensive testing and certification to fulfill the strict international aviation regulations. This procedure requires a series of rigorous studies, including safety, performance, and environmental impact evaluations, all of which are necessary for receiving certification from regulatory agencies like the FAA and EASA. The testing step is time-consuming since it involves extensive validation in real-world settings to assure the engine's durability and efficiency. The UltraFan will only be considered suitable for commercial usage if it has successfully passed all of these assessments. Scalability and manufacturing. In order to fulfill the growing demand for the UltraFan, a significant investment in manufacturing facilities will be required to increase output. Rolls-Royce will have to upgrade and expand its facilities in order to be able to manufacture engines more effectively and in greater quantities. In addition, it will be essential to maintain a constant level of quality and dependability as production increases in order to preserve the brand's reputation. As production increases, strict quality control procedures and extensive testing will be necessary to guarantee that every engine matches the high standards established by Rolls-Royce. Market adoption. It may take some time to persuade airlines and manufacturers to use the UltraFan engine, particularly since the aviation sector is sensitive to costs. The significant initial expenditure required may discourage some stakeholders from adopting new technology, despite its long-term benefits. Airlines may be reluctant to invest in such a costly improvement without rapid rewards, since they often operate under strict budgetary limitations. However, as fuel economy improves and running costs reduce over time, the UltraFan's potential to provide considerable long-term savings may ultimately surpass the initial expenses. Number 1. The path forward. In the effort to achieve net zero emissions by 2050, how will the UltraFan influence the future of aviation? The Rolls-Royce UltraFan engine is an important advancement in the aviation industry that will help make air travel more sustainable and efficient. The engine is now in the demonstration phase and has already passed successful tests, demonstrating its advanced design and features. The UltraFan has the potential to significantly lower carbon emissions and operational costs, which is one of its most innovative characteristics. This aligns with the aviation industry's increasing commitment to sustainability. The UltraFan has a new design that has a bigger fan diameter and better materials, which results in a substantial increase in fuel economy. This might change the way commercial aviation operates. The creation of this engine demonstrates how Rolls-Royce is taking a proactive approach to achieving environmental goals across the world. The UltraFan might be a model for future propulsion systems as the aviation industry continues to change. This could encourage other manufacturers to develop and push the limits of what is feasible from a technological and environmental standpoint. In the end, the UltraFan is more than simply an engine. It is a driving force for a future in aviation that is both more sustainable and less expensive. Hit like, share, and subscribe for more.